So, have you ever wondered what happens when you hand a really, really powerful AI one of science's toughest unsolved problems? Well, a brand new paper just gave us a peek behind that curtain. And honestly, the results are kind of mind blowing. Okay, let's get into this. For most of us, AI chatbots feel a bit like a super smart text predictor, right? We've all used them, you ask a question, and it spits out some text. But is that really it? Is it just a fancy autocomplete without any real creativity or deep thought? Well, a new paper from some heavy hitters at Google Research and a bunch of universities is saying, hold on a minute. They're showing that these advanced AI models are evolving way beyond simple tasks. They're becoming actual, genuine partners in the creative, messy process of scientific discovery. And we're not just talking about doing old stuff faster. No, this paper is hinting at a total shift in how research gets done, a real partnership between human scientists and artificial intelligence. This quote from the paper's abstract really nails it. The key words here are versatile and genuine partner. The AI isn't just a fancy calculator anymore. It's right there in the mix, actively helping discover new things. So how are we supposed to think about this? Well, the researchers came up with a really great analogy. They say to imagine the AI as a tireless, knowledgeable, and creative, bright junior collaborator. Think about it, a brilliant research assistant who's read basically every paper ever published, never needs to sleep, and is always up for brainstorming. And look, this isn't just a what-if scenario. The paper is just packed with real examples where researchers used models based on Google's Gemini to make actual progress on problems that have been stuck for years. Okay, so what's the secret sauce? How does this actually work? Well, it turns out there's kind of a playbook emerging for this new kind of science, a set of techniques researchers are using to really unlock what these AIs can do. First on the list is something called iterative refinement. This is key. You don't just toss a huge problem at the AI and say, go. It's a conversation, a real back and forth. The human expert steers the ship, points out when the AI is making a mistake, and helps break the big problem down. It's a dialogue. And this diagram really shows you what that dance looks like. You see the human kicks things off with a problem. The AI goes out and explores this huge space of possible answers. And then, this is the important part, the human gives feedback, which helps guide the next step. It's a loop, a partnership. Now, the second technique is where things get really wild, cross-pollination. Because the AI has ingested such an insane amount of information from all over science, it can spot connections a human specialist might never see. It can grab an idea from one corner of mathematics and apply it to a totally unrelated problem. And you can see it right here. On the left, the AI took a problem about dots and lines and saw its connection to smooth spheres, using a totally different kind of map to get a fresh perspective. And on the right, it sifted through its massive library of knowledge to pull out this obscure but perfect tool, the Kears-Brown extension theorem, which turned out to be the exact key they needed. This all builds up to one of the most futuristic techniques in the playbook, neurosymbolic loops. This is where the AI doesn't just brainstorm ideas. Oh no, it writes its own computer code to check if its ideas are right, which grounds all its abstract thinking in cold, hard, verifiable results. So here's how that loop works. Step 1, the AI comes up with a mathematical idea. Step 2, it actually writes code, like a Python script, to test that idea. Step 3, if the code breaks or gives an error, that feedback goes right back into the AI, which uses it to correct its own thinking and try again. It's basically debugging its own logic. It's amazing. All right, so we've got the playbook, but did any of this stuff actually work? Did it lead to anything big? Oh yeah, let's get into the real-world breakthroughs. So our first case is like something out of a science thriller. A new cryptography paper gets published claiming a massive breakthrough. It passes peer review, human experts looked at it, but there was a tiny hidden flaw that everyone missed. And the AI found it. And get this, it wasn't some obvious mistake. The paper calls it a subtle inconsistency buried deep inside the logic. This is something you'd only find if you had a really deep understanding of the material, not by just scanning for keywords. So how did it do it? With a super clever trick. The researchers didn't just say, hey, review this paper. They made the AI argue with itself. First, write a review, then play devil's advocate and poke holes in your own review, then go back and fix it. This process forced it to be incredibly rigorous, more rigorous than the human reviewers. And it wasn't a fluke. In another case, the AI went up against the simplex's best conjecture. This was a really tough, long-standing problem in a field called computational geometry that had stumped mathematicians for a long time. And here we go again with that cross-pollination thing. It cracked the case by connecting the problem to that obscure Kurzweil theorem we talked about earlier. It built this elegant, beautiful proof that human experts just hadn't seen. So these breakthroughs are obviously huge. But the paper doesn't stop there. It looks ahead and asks a really important question. What does this new, super fast pace of discovery actually mean for the future of science itself? And this is where they raise a really critical warning flag. They talk about a new challenge on the horizon called the shifting bottleneck. Basically, as AI helps us solve one problem, a totally new one pops up. And this slide just lays it out so clearly. For basically all of human history, the bottleneck, the slow part of science, was coming up with new ideas. But now, with AI, we can generate ideas like crazy. The new bottleneck is verifying that absolute fire hose of AI-generated ideas. This has a really big consequence. The paper warns that we could be headed for an impending crisis in peer review. I mean, think about it. How can our current system, with a limited number of human experts, possibly keep up with this flood of super complex AI-generated research? But even with that challenge, the overwhelming feeling you get from this research is just incredible optimism. We're looking at a tool that can be a real partner in discovery, a collaborator that helps us see the world in new ways and solve problems we thought were impossible. Which really leaves us with one final and very exciting question. If this is what AI can do today, what on earth are we going to discover tomorrow?